The next topic is the magnitude of vectors. So first consider the vector 2i plus 3j. The magnitude or the length of A is represented by the symbol modulus. I'm pretty sure we learned this in either functions or quadratics. And by Pythagoras theorem, we have A squared is 2 squared plus 3 squared, which is 13. So therefore, the magnitude of A would be root of 13 because the length is always going to be positive. We're not going to have negative 13 units. And therefore, it's going to be plus root 13 units. So this is the general formula. If A is A1i plus A2j, the magnitude or length of A is the square root of A1 squared plus A2 squared. It's just like finding the Pythagoras theorem. And if we've understood that, let's solve the questions. We have to find the length of this. So it's the square root of 1 squared plus 1 squared. We have square root of 1 plus 1, which is square root of 2. This would be square root of 5 squared plus negative 12 squared. It's going to be 25 plus 144, square root of 169, which is 13. We have minus 1 squared plus 4 squared. It's going to be 1 plus 16, which is square root of 17 units. The next one, we have to find the magnitude. The word magnitude and length mean the same. It's going to be square root of 3 squared plus 4 squared, square root of 9 plus 16, square root of 25, which is 5. It's going to be square root of minus 4 whole squared plus 3 squared. It's going to be square root of 16 plus 9, square root of 25, therefore 5. That's the answer. We have to find k for the unit vectors. Alright, so we have to make this the unit vector. Therefore, square root of 0 squared plus k squared is 1. Let's square both sides. And k is plus or minus 1. The answer would remain the same for this also. K is plus or minus 1. Now we have to find the length of this. I think we already did this question. Yeah. Okay. Which of the following are unit vectors? Let's find this. Square root of 0 squared plus minus 1 squared. This is going to give us 1. Therefore, this is a unit vector. And now we have this one, square root of root 2 whole squared plus 1 divided by root 2 whole squared. It's going to be square root of 1 divided by 2 plus 1 divided by 2, which is root of 1, therefore 1. Alright, so we have the magnitude of V is root 73. So it's 8 squared plus b squared. Let's square both sides. 8 squared plus b squared, 64 plus b squared. 72 minus 64 is 9. Therefore, b squared is 9. And p is plus or minus 3. That's the answer. Next topic is operations with vectors. We have 3: addition, subtraction, and multiplication. In vector addition, we just have to add the x components and then the y components. So just imagine we have the vector a, which is a1, a2, and B, B1, B2. Notice that the horizontal step for A plus B is A1 plus B1, and the vertical step would be A2 plus B2. So you just have to add these two, and then write it like this. So this is what you need to do. And this is the diagram. You can look at it. So if this is A and this is B, then the resultant addition would be this. This is A plus B. And now the x component of this would be A1 plus B1. And this would be A2 plus B2. And that's how you do it. And subtraction. So to subtract one vector from another, you just have to add its negative. So if we have vectors A and B, let's take C and D, and we have to do A minus D. We just have to find the opposite of D, or the negative vector of D, and then add that to C. And that's what they have written over here. It's A minus B is A plus of minus B. And therefore, we just have to subtract A1 minus B1 to find the x component, and we have to do A2 minus B2 to find the y component. That's all. It's very simple. And now let's look at the diagram. If this is B, this would be negative B, because it has the same magnitude but different, like opposite direction. And this would be A, and A minus B is A plus B, and therefore this would be A minus B. The final topic under this is scalar multiplication. We multiply vectors by scalars such as 2 and minus 3. And it can be any real number. It doesn't have to be like an integer and so on. So if A is a vector, we define 2A as A plus A and 3A as A plus A plus A. And so this would be A, 2A is just going to be double of that, and 3A, 3 times of this. And if we have a negative, it's going to switch direction. If it's going this way, it's going to go back. And that's all you need to know. So 2A is the same direction as A, but twice as long as A. 3A is the same direction as A, but 3 times longer than A. Minus 3A has the opposite direction to A and is 3 times longer than A. So 3A and minus 3A are negative vectors. And yeah, this is the general thing you'll need to know. If A is a vector and K is a scalar, then K into A is also a vector, and we are performing a scalar multiplication. There's something called as vector multiplication, but you won't have to know this until your A levels in further math. So right now it's not required. If K is greater than 0, then KA and A have the same direction. If it's less than 0, they have opposite direction. Because if you multiply it by -1, the direction changes. And therefore, if K is less than 0, it's going to switch direction. And if K is 0, then we're going to have a 0 vector. And therefore, if we have V, KV would be K into V1 and K into V2. And that's all you need to know for addition, subtraction, and multiplication. And now we'll solve questions based on this. These are the questions. Take a couple of minutes to solve them yourself, and then once you're done with that, I will work it out. All right. I'm hoping that you have solved these questions, and now I'm going to solve them. We have to find 3q. This is scalar multiplication, so this is going to be 3 into 2 minus 3. It's going to be 3 multiplied by 2, 3 multiplied by minus 3. This works like multiplication. It's not complicated. It's just very simple. And now we have to do B, multiplication. This is addition, and this would be multiplication. So P is 4, 1 plus 2 into 2 minus 3. We first multiply 2 into 2 and 2 into minus 3. We get 4 minus 6. And now we have to add the x components, which is 8, and add the y components, which is minus 5. That's how you do it. And now let's do C. It's half P minus 3Q. We've already found 3Q, so we'll just sub that in. But half of P would be this. It would be 2 half, 2 and a half, plus minus 6, 9. When we add these, we get minus 4 and 9 and a half. So this is how you do addition, subtraction, and multiplication. Time for this one. Suppose A is this, B is that, and C is that. We have to find A plus B. A is 2i minus j, and B is I plus 3j. We have to add the x components and j components. It's almost like, what is that? Like term addition. You know, this is I and I, this is j and j. You can't add these two, you can't simplify it further. So it's going to be 3i plus 2j. Let's do B. 3 into 2i minus j plus minus 4i. It's 6i minus 3j minus 4i. We get 2i minus 3j. Let's look at C. 2b minus a. 2 into I plus 3j minus of a, which is 2i minus j. It's going to give us 2i plus 6j minus 2i plus j. These get cancelled, and we're left with 7j. Now we have D. It's telling us to find the modulus of C plus A. When we say modulus, we mean the magnitude. So first we have to find C plus 2A, which is going to be minus 4 plus 4i minus 2j, and we'll have just minus 2j. So the magnitude is 0 squared plus minus 2 squared, which is 2 units. That's the answer. Here we have to find the magnitude of P in the first question. It's going to be square root of 1 squared plus 3 squared. We have square root of 10 units. And now let's do B. B is 2 into P, so square root of 2 squared plus 6 squared. Square root of 4 plus 36, square root of 40 units. You can simplify this further, but we can leave it like this. And let's do F, magnitude of Q, so minus 2 whole squared plus 4 whole squared. We have 4 plus 16, so square root of 20. 4Q is minus 8 16. The magnitude would be square root of 8 squared plus 16 squared. Let me work that out, which is 8 root 5 units. And now let's do this question. We have to do P minus Q. So it's going to be 4, 2, minus of minus 1, minus 5. Minus 4, 2, plus 1, 5. It's going to be 3, 7. Let's do B. Q minus R. And then we have D, which is P minus Q minus R. Is going to be negative 3, so negative 6. 2 plus 5 plus 2 would be 9. And now try to solve the last question. It's going to be easy. Q is minus 4. No, minus 4, sorry. Minus 1, minus 5. 3 minus 2. And then minus B. We had 0 on top and minus 5 here. And therefore this is 0i minus 5j. And with that we finished this subtopic.